Section 9.3.15-T. A jar of peanuts is supposed to have 30 ounces of peanuts. The filling machine inevitably experiences fluctuations in filling, so a quality control manager randomly samples 12 jars of peanuts from the storage facility and measures their contents. She obtains the accompanying data. We're going to complete part A through D. So we want to verify that the data are from a normally distributed by constructing a normal probability plot. So what we're going to do is we're going to take our information here. We're going to open it up in StatCrunch. Okay, and then the first thing we're going to do is we're going to go to Graph, select QQ Plot, Variable 1, make sure that normal quantiles are on the y-axis, and then select Compute. And then therefore we can see that it gives us the following graph. Okay, now if we wanted to edit this graph a little bit, let's say that we wanted the y-axis to go from negative 1.75 and then to 1.75. So what we would do is we would select this button here and then select the y-axis and then put in our information. Okay, and then if we want to change our x-axis to go from, let's say, 29 to 30.4, then we would select OK, and then we can graph that picture, and you can see how it's slightly different depending upon our scale and how we sort of maximize the y-axis and the x-axis. But regardless, we can see that this creates a normal distribution because it creates an almost line there. Okay, now we want to determine the sample standard deviation. So what we want to do is we're going to come back to our data. We're going to select Stat, Summary Stats, and go to Columns. We're going to select Variable 1 for our column, and then we want the standard deviation. And then we're going to select Compute. So let's go ahead and compute that. And so therefore there is our standard deviation. Okay, now we're going to construct a 99% confidence interval for the population standard deviation of the number of ounces of peanuts. So the first thing we want to do is we want to determine, okay, what is the sample size? So we know that the sample size, n, is equal to what? Well, in our problem, we have 12 jars. So we know that there's 12 jars, so the sample size is 12. So if we take 12 and subtract 1, then the degrees of freedom is going to give us 11. Okay, and then what we want to do is figure out what alpha is. We know that alpha is going to equal 100% minus 99%, which is equal to 1%, which as a decimal is 0.01. And if we take alpha divided by 2, 0.01 divided by 2 is going to give us 0.005. Okay, and so now what we want to do is we want to be able to determine what is the critical value of the area of 0.005 with the degrees of freedom of 11. Okay, so we can either use StatCrunch or we can use the table. Let's use StatCrunch right now. Okay, so we know our degrees of freedom is 11. We know our area is 0.005. And what do we get? We get 26.756849. Okay, so this is the number that we get from StatCrunch. Okay, and so let's go ahead and round that number to 26.757. Okay, now if we wanted to, we can come down here, and if you can see here that here is 11 and there is 0.005, and we get 26.757. Okay, so now let's find the lower bound. So the lower bound is going to equal the value of n, which is 12 minus 1. And the standard deviation we have up here, we can round that to 0.340. that is our standard deviation. So we're going to take 0.340 and square it, and then divide that by the critical value of 26.757. And so therefore our lower bound is going to be approximately 0.047. Okay, so same thing with the upper bound. We know our degrees of freedom is 11. We know that alpha divided by 2 is 0.005. And we want to find the critical value of 1 minus 0.005, which is the area of 0.995. So let's go ahead and use StatCrunch here. So if we put 0.995, then we're going to get this critical value of 2.603. So we get 2.603. Now let's find the upper bound. So we know we have 12 minus 1 times the sample standard deviation of 0.340 squared divided by 22.60, and therefore the upper bound is going to be 0.487. Okay, and so now what we want to do is, since this gives us the variance, we want to find the standard deviation. So we're going to take the square root of the lower bound and the square root of the upper bound. So the square root of 0.047 and the square root of 0.487. And so rounding it to 2 decimal places, we get 0.217 and 0.698. And so from here we can say that there is a 99% confidence that the population standard deviation of the number of ounces of peanuts is in between 0.217 and 0.698 ounce. Okay, and last question here says, the quality control manager wants the machine to have a population standard deviation below 0.20 ounce. Does the confidence interval validate this desire? What that means is 0.20 in between these two numbers? Well, the answer is no, because 0.217 is higher than 0.20. So therefore, we're going to say no, because the lower bound of the confidence interval is greater than 0.20.